All right, number 16 asks us to state whether the graph is increasing or decreasing. Again, increasing, decreasing, also positive, negative. You are traveling from left to right, and you're going to tell me x values to answer this question correctly. So forgive, we should have some nice arrows on the ends of our graph. Okay, now I'm going to start on the far left. So I'm starting at negative infinity. I'm going to go all the way across and think about going to positive infinity as I travel this graph. Now I'm traveling from left to right, and again I kind of like to highlight these just to show people what's going on here. So increasing and decreasing, if I start from the left, you want to think about this as you are tracing the graph. So if I'm tracing the graph right now as I'm traveling from left to right, this part of the graph is increasing, and that's going to stop right at this point right here where we're just flat, and then we're going to switch over to decreasing. But let me go ahead and write that interval kind of as I go. So at this point, this is this negative 3.667, you're switching over at that x value. So from negative infinity to that point, this graph, or this part of the graph, is increasing. So I'm going to write from negative infinity to negative 3.667 for that interval. Now at that point we're just flat, but then the graph turns, and as I'm tracing this now I'm going down, 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 down as I go to the right. So this interval is decreasing. So I'm going to make myself a second, probably should have left a little bit more room here. Decreasing. Okay, now again, this is switching over at this point, but make sure you look at the x value, which is actually just a nice number there. It's just the number 1. So as I'm traveling from left to right between this negative 3.667 and the 1, that's that orange part on my graph, so that's decreasing. And again, at these points, kind of like it was with positive and negative, that point right there is not considered increasing or decreasing because it's where I'm turning direction, so it's just kind of flat there. So that's why you're going to see parentheses in these intervals and not brackets. As I continue to trace the graph from left to right, the rest of the graph, as I go all the way to the right forever, is going and traveling up. So this is increasing here for the rest of the graph. So that switches over at 1. The rest of the graph as I travel to the right is increasing. So that's where that positive infinity is going to come from 1 to infinity. 2 intervals are increasing and 1 interval is decreasing on that particular graph. Okay. Let's go ahead and switch to number 17 here. It says a model for a company's revenue from selling software package is given by R equals negative 2.5p squared plus 500p. P is the price in dollars of the software. What price will maximize revenue? Anytime you see a maximum question, you are going to be looking for the vertex. So let me just, I'm going to come down here and rewrite this equation real quick so it's all on the same line. So in this case, if I were to kind of set up points for this graph, P would be where you would expect to have your X. So that's going to be your price. And the R is where we usually see the Y. So that's going to be the revenue. Now, in this situation, maximum, if you guys think about what the graph would look like here, it's p squared, so it'd be a parabola. This is negative 2.5. So I know if we were to put this on a graph, it would turn x upside down, and, or not x upside down, just the whole graph would turn upside down. So I will have my vertex being a maximum. So all you got to do for your vertex, negative b over 2a, and then plug in negative b over 2a. Now, for this question, opposite of b would be negative 500 over 2 times a. Now, this is super important. I'm going to grab my calculator here real quick so I can show you. You have got to put this in parentheses, or you have to figure out what that product is before you do the problem. So, let me grab my calculator here and show this to you. Negative 500 divided by 2a should be 2 times negative 2.5. See, I'm forgetting the division sign. But I am going to put this in parentheses. And you guys can see I'm going to get 100. Now, let me show you, if I don't put parentheses, how I get a totally different answer. Get rid of those. There we go. Okay, see here, what's going on? It's doing negative 500 divided by 2 and then multiplying the result by the negative 2.5. So either figure out what that product on the bottom is or put it in parentheses so you get the correct answer. Now, once you have that, that's the price. And all I'm going to do here to get my other answer to the rest of the question for the revenue, so P is going to be 100, I'm going to plug 100 in for the P in the equation. So negative 2.5 times 100 squared plus 500 times 100. And this will give us the revenue, which is going to be the 25,000. So anytime you see maximum or minimum, it's just asking you to find the vertex. And so that's the negative b over 2a, and then plug that number back into the equation so you can go ahead and get the y value there. Okay, y-intercept. For any graph, where you cross the y-axis, the x value has to be 0. If you're on a graph and you're crossing the y-axis, that's what your y-intercept is. The x value will always be 0 at that point. So all you're doing is replacing any x's you see with a 0. Now, as I go through and do this, negative 1 squared is going to become positive 1. So we don't multiply these together and then square it. We square first, multiply it by 2. This is going to actually just end up being 2 plus 7, which is 9. So the y-intercept is the 0.09. If you just need the y-coordinate of that point, it's just the number 9. Number 19 says write this in standard form, and we're going to identify the quadratic, linear, and constant terms. Just going to use a FOIL here, or double distributive property, or draw yourself a box if you like that. 4x times negative 3x, negative 12x squared. 4x times negative 5, negative 20x. 1 times negative 3x is going to stay negative 3x. 1 times negative 5 is negative 5. Just going to combine my like terms here. There's only one term with an x squared, just that negative 12x squared. Negative 20, negative 3, negative 23x's. There's only one term with the plain number, that's the negative 5. Okay, now in terms of this, your quadratic term is the term that's squared, so negative 12x squared. Your linear term is the term with the plain x, so negative 23x. And your constant is always just a fancy way of saying the plain number. That's going to be negative 5 for this problem. Number 20, I'm looking at that going, there's an absolute value, so I know this is going to be a V shape. Now, to get your vertex, you're just going to do opposite copy. So inside with the x, positive 1 is going to be the x-coordinate. Copy, that's going to be your y-coordinate. This is going to be my vertex. Now, out in front of the absolute value is going to affect the slope if there is one. This doesn't have anything written out here, so my slope on either side of the V shape is just going to be 1. So find yourself this point, 1, negative 2. All right, now, nothing's turning this upside down. This should just be positive 1. So I'm going to go up 1 over 1 on either side of the vertex to create the V shape. Now, this is greater than. So a strictly greater than should be a dashed or dotted line, and greater than goes above. So we're going to have some shading here. I'll just continue to draw little dots here for my dashes or whatever, something like that. And greater than goes above, so we would shade above our boundary line here. So all these points above the V shape are going to be solutions to our inequality. Polynomial equation with rational coefficients has roots. Roots is another word for zeros or answers, depending on how your teacher may have talked about that. So these are answers to a polynomial equation. Find 2 additional roots. All you have to do here is write down the conjugates. If 2 minus radical 2 is a root, 2 plus 2 is automatically also a root. Same thing here. This would just change to 4 minus radical 5. The concept behind this is we must have done some kind of solving, and we would have ended up with maybe a quadratic formula that had this plus or minus radical 5 like that. So if they give you one, you automatically have the other. They always come in pairs. So we're just looking for these two answers for this question. For 22, state the domain and the range. The domain in no particular order. If these are just coordinate points, there's no connection, there's no graph, nothing is showing us anything here except for these points. You literally just list the x coordinates, and they don't have to come in any particular order. So each of these is different. If any of them had repeated, I would have only written them once, but those are just the x values. Range, we're going to write down our y values. So I've got -3, 1. Now, -3 appears a second time. I just write it once. And -9. Again, no particular order is necessary. I just wrote the coordinates as they appeared in each of the points. So domain, these are always your possible x values, and your range is always the possible y values. Okay, a couple options for number 23. You can factor this. This is the difference of cubes. A cubed minus b cubed would factor into a minus b, a squared plus ab plus b squared. You'd have to recognize what's being taken to the third power. In the problem, 64 is 4 to the third power, so I would need that a would be replaced with an x, b would be replaced with a 4. So here'd be my factored form here. A times b would be 4 times x, and b squared would be 16. Okay, now we're trying to write the answers to this question. So this would be 4, and then what we would have to do here is the quadratic formula because this doesn't factor. I just want to show you quickly another option, maybe if you don't have that formula memorized or you don't have it written down for yourself. Let me go to the y equals screen and let me clear out some stuff we have. I'm just going to type in that x to the third minus 64, and I'm going to hit graph. This is just another option. So on the graph you can see this goes through at 4. Now, if I look back to the original problem, I know I'm supposed to have 3 answers to that question because it's x to the third. So if I can take that 4 from the graph, already I've got one of my answers. And you guys would have gotten it from the factored form also. But another option, if you don't want to use the factoring, you can actually use division. The really tricky part to this is you are missing 2 powers of x. I don't have an x squared and I don't have an x. So if you want to do this with a graph and synthetic, you can, but you got to remember if you're doing synthetic division, if you're missing any powers of x, you're going to replace those with a 0. Now if you go through here, you're going to see I shouldn't get a remainder. This is my plain number, my x and my x squared. So 4 was the 0 we saw in the graph. X minus 4 would be the corresponding linear factor. And that's what my result was when I got synthetic. And you guys can see these are exactly the same. So it's just 2 different ways to do it. If you want to use that factorization there, or if you want to use the graph, get yourself a 0 and then break it down with synthetic division. Both of those methods work. Okay, now, as I've said like 3 times while we're doing the problem, one of the answers is 4. So I saw that on the graph. I got to do quad form on what I have left. So opposite of b plus or minus, I'm going to go ahead and write this out. So b squared would be 4 squared minus 4, whoops, let's grab some parentheses, 4 times my a value would be 1 times my c value would be 16. This is negative 48 over 2. Now, however you want to break down that radical, if you want to use the biggest perfect square, that's how I break it down. This would be negative 16 times 3, which would break down to 4i to take care of that negative radical 3. If you want to do a factor tree, go for it. You should get the same result. Now, just a simplified version of this. Remember, we're supposed to have 3 answers to the question because it was x to the third. One of them is 4. In this case, don't be touching that radical, but all 3 of those numbers there are divisible by 2, so you can actually do that division. So this would simplify 2 plus or minus 2I radical 3. These are the other two answers, and they would be imaginary because we didn't see them on the graph. So 4, and then this is two different answers with the plus or minus, -2 plus 2I radical 3 and -2 minus 2I radical 3, also solutions. Okay, factor completely. This factors just like a quadratic. I need two numbers that multiply to get me -25 and add to get me -24. So I'm going to use -25 and 1. And what I need to recognize here, this is just a factoring question. We're not solving anything. There's no equation here. However, this factor right here is what we call a difference of squares. So I can factor this down a little bit further. This would be x minus 5, x plus 5. That is not true for this factor. You can't factor this because it has imaginary values that it would factor in down to, so we're just going to leave that alone. You can only do that for a difference of squares. That's got to be a subtraction between the two. So this would be your completely factored form for number 24.